Millennium to power millennium. Good morning, good day to everybody. This is Engineer Suraj Singh speaking for Bharat India on this day, March 23rd, 2022, Wednesday, 3:40 a.m. नमस्कार, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज मार्च दिनांक 23/22/2022 बुधवार सुबह के 3:40 मिलेनियन मैंने बोला इंग्लिश में बिकॉज इट इज इंग्लिश. आई डोंट नो व्हाट्स मीनिंग इन व्हाट्स कॉल्ड इन हिंदी. आई डोंट नो. I use term millennial just for your information, also for part of education. MILLI and million, ILLION, illion. Millennial, which means 10 to power 3003. That is meaning of that. 10 to power 3003. This means if you use 1 and write 3003 zeros, you shall get a value which is equal to millennial. It's for your extension of information. And what is the equivalent of Hindi? I actually am sorry to say I don't know what's that. Well, let's move on subject and let's talk of power of communication, concrete statement. And I did write a statement, but concrete means concrete material and concrete statement. Civil engineering, contracts, safety, health, environment. See, just I started and signals are 00 again. This was happening. I don't know where is quality between. No, there's no quality in Airtel. You can say just now I started and it's gone 00. Well, again comes 46 kbps and designs, methods, disputed claims. I changed claims to disputed claims. And parties means in place of organizations I have put parties because of contracts. And what we are ultimately, that is at hand. So we say I started from real quality, and I at one end I put real quality, at another end of this string I put what we are, and that's what we have to think on. And here is my board, identification board, official identification board, which shows that I'm a chartered engineer in this country, Bharat, India, and also I'm registered on International Register of Professional Engineers, which is controlled by Institution of Engineers India. Its representation, it represents our country on international register. And my email ID is at yahoo.co.uk. If you are requested to write to me on this, also I have phone number, but I am not interested in the phone number because of disturbances from various people. A better writer, if any, you have certain query or certain question, or simply to suggest something to me so that I can make improvements, please write to me on this email, suraj_engineer@yahoo.co.uk. Also, there is another email I'm not showing here, and that is Suraj Singh PE. Suraj Singh PE. My name is Singh, Suraj Singh PE at gmail.com. So now continuing about this, I have to say let's go to another file. That is my certification file. As I said, International Register, International Professional Engineer India, on International Register of Professional Engineers, and that is CE, that is Chartered Engineer India, which is linked to corporate membership of Institution of Engineers, as this is 16. Till that time I was member of institution, and since 1981 I have been member. 86, I'm sorry. Since 1986, from 1986 to 2016 I have been member. That was MIE. And before that, 1981 to 1986 I had been associate member. So I have been on 3 positions. Associate member when I was too young, and when I was little grown up it was membership. And now when I am 68 now, this means age of 66 or 62, I got fellow membership. So you can say it's a senior position it is. And this is quality file, which is point of exposition here. I'm too serious, and I hope everybody should be serious. And here is coordination issues, coordination engineering, which is very much required in life as well as in work. And this is file called concrete file, which was downloaded to, I think, last week or before that. This is issue of Japan Association of Engineers, and I can close this file now because so many files are open. So chartered engineer is closed and fellow is closed. So remaining files I keep on my board so that I can put this in between for reference to this person, and also I can refer to somewhere, say half an hour, 1 hour. Now I'm talking about quality issues. What is quality? Why should we not be concerned? I am very much upset with quality we are having in every sector of life, not only in civil or construction engineering, but even in electronics, you can say internet, Airtel or many others. There is no constant transmission of signals even, and that's what I say. Every work in our life is affected by quality and coordination. If quality is not controlled, what sort of people we are? I do not understand. 130 crores people in this country, 130 crores or 1300 million people in ours, Bharat, India, and we are not serious about quality. And out of this 130 crores, I think there must be 30% highly, or you can say considerable, educated classes, or maybe more, but let me take 30% who can be relied upon, and this means about 40 crores people, 400 million people, based on which we call ourselves knowledge society. Knowledge society means having knowledge about all issues in life, all, whether it may be engineering or it may be medical, it may be business, it may be commerce, it may be law, it may be whatever else you can say. There should be no dearth of knowledge in our country. We should have knowledge about quantity and quality both, but I think maybe we have knowledge, but we are not capable to use that knowledge. We have knowledge only in formality and not in reality. There is a difference, formality versus reality. Formality is something that is displayed like it's a showroom, and reality is that what we do in real life, not in real life. Documentary is not important, real is not important, but REAL, real is important, and that's why I use term reliable engineers or reliable work or reliable activity, or you can say reliable decision. Reliability means which can be taken, or which can be you can say relied, you can be depended upon every time. Repetition is possible, and we have to be very serious about issue of quality and coordination, because this system is very important. Quality does not mean quality. This should be real quality. That's my point. Real quality means not quality just to show, but to quality to continue, quality to deliver. If I'm not delivered good quality that I expect or that's promised, certainly I get upset. I can't do anything. What to do? I can alternative, because if a purchaser is not serious, a seller shall also not be serious. That is a very understandable answer. I'm not serious because who bothers? Okay, next time I won't buy from this vendor only, I can say. But I have bought already one time. This means that vendor has got profit. And likewise, that vendor sends to millions of consumers, that keeps on getting profit in continuity. So point is that if you get your purpose served, purpose for which you are working in market is selling or promoting your product, there's no issue. Even if one person comes in and fights with you, there is no meaning of that fighting, because person is also not supported. In this era when support is very easy, and we can say quality has died. That's what I can say. Whatever level quality existed in ours, it has died, and that is really very unfortunate situation that we have lost quality. We do not care for quality. And quality and coordination therefore should be clubbed together, but we have not even cared for these. If you talk of quality to young people, you won't get any answer because they don't understand. They only understand life should be comfortable, they should get all facilities, and they are getting it due to whatever reason. They don't care for quality, they care for momentum, they care for quantum. And that's why seriousness does not exist. And I used to write many postings about that we are not serious society, we are not serious people, and that's a fact. Seriousness has gone somewhere, I don't know where, I can't locate it. Well, it's no use to beat about bushes. I should come to point, and coming to point is that we have been sleeping and we have to be very serious. We have to adopt quality, otherwise we cannot be called knowledge society, as quality also is a part of knowledge. If you don't have quality knowledge, our other knowledges do not have any meaning. We cannot be called world people, we shall be called only our country people, because we don't understand what we have to do. So that is what I say. I try to and that is our greatness that we forget. We are so big people, we can't keep best requirements in our mind. We only keep superficially whatever we like. Again, zero singles, and that's why I say I really, how many times I have to return to them, only I know. I have, but they only answer same all time. We shall take care of this, we do that, and well, no meaning of again talking same. I don't know how many minutes this video continues. Depends. Quality engineering and coordination engineering are very important branches of or domains of engineering within engineering. And if these are not taken care of, we cannot get good working designs, we cannot get good working manufacturing, we cannot do construction procedures as required. And to do it can continue mistakes. We cannot fix quality as a country. We have failed, and we talk of national standards and international standards, but we don't have any standard, to be very frank. Everybody doesn't care, even there is concession or no concession, they automatically grant themselves concession. Consumers don't worry, manufacturers don't worry, government does not worry, people do not worry, and there is no one to worry about in that case. We have to find people who are worrying, who are concerned, who are serious, and we don't find anything. Our media are not educating classes now, they are just a commercial. You can take television channels, you can take print media, you can take whatever, consider yourself. You don't find that they are professionals. I cannot call today that these media people are professionals. I can't call today law related agencies are professionals, because they don't care for time. Lawyers don't care for time, courts don't care for time, government doesn't care for time. When time is not valued, you can say nothing is valuable. We don't value time, this means we don't value ourselves. But once time goes away, it doesn't come back. Time is not my servant or your servant. We are servant to time, in fact. And we neglect it, we ignore it, and if we ignore ourselves, we have to understand value of time. So time is relative, I know it's relative, but it is for us. This means we cannot achieve quality because we don't care for time. Control of time itself is a quality issue. We cannot do, if we waste time, this means we waste everything. So work's quality cannot be compromised. We have to say, without intent to compromise, just in name of a fragile system, we make our systems at national and international level both, but we do not care for them because we just make system and think it's working automatically, complying automatically. That's just a formality, nothing. I can say today these systems have got no meaning because products don't have quality inbuilt or quality coefficient to requirement. Therefore, quality is not in system, quality should be in product, and quality system does not guarantee that you shall get quality product. Quality is not in system, quality is not in material. This means there exists no quality in professionals, there exists no quality in workers, there exists no quality in technicians. Everywhere quality misses. we try to say I have done so much work, but what percentage of quality I have done, I also don't know, because it is not one person job. You take manufacturing, you take processing, you take construction, you take others. It is a group job. Nowhere where one person works self. That is the professional freelancing job where you can expect, if you are interested, you can get quality. Otherwise, you cannot get. So again, I say our consultation should be, where do you exist in the idea of quality? I am in search of you. Please come and tell me. I want to take your help, and please give me help. But he says, I have already helped. I have been helping. You are not serious about me, so why should I be serious about you? I don't find any answer from there, or you can say I don't find any reliability from my friend quality, who has defriended me, who has thrown me out, because we don't respect quality. Quality lies within our minds, within our conscience, but we don't use it, and this means that we are red lines ourselves and not others. And can we bring it back? My question is, can we bring working environment to quality and coordination requirements? And if we yes, I say yes, how to do it? And if I say no, why? This is they're not written all this here, but that is interpretation, that is, you can say, construction of what I'm saying. And I say certain red lines that must be turned green, that's important, and that must be a must. It's not simply saying it should be, that must be a must. This means it has to be done. So can we know and apply quality standards? That's my question to myself and to yourself. Can we know and apply quality standards? Okay, we know something, we know everything, we know books, we know rules, we know standards, we know everything, procedures, all that. But can we apply? That's my question. Or we can say, we always say we are leading society, we are going to be number one in world, or we are going to lead others, but can we even equalize ourselves to existing situations, to existing countries near us or around us? We do not know about that. We only say we direct you, while we do not direct ourselves. That's what I say. I have given an example of GCC countries, Gulf Council, Cooperation Council, Gulf Cooperation Council countries, where there are 6 or 7 countries, I think. There are 7 countries. And if you even follow them in quality, you can change yourself. Our engineers go there, have been going there, I have been where they are. And I know how they systemize everything. They are serious people. They don't want to waste money, they don't waste time. And they do something durable. But we never learn from there. We go there, we follow it, and that's why I'm talking to you, because I have done on that. Of course, there's a variation quality in South there. You can take question, you can take consideration, you can take in your hands question of Qatar, or question of Saudi Arab, Kuwait, Bahrain, or UAE. Likewise, you will find variation in quality, but even then, seriousness does exist there. Iraq, you can take example, which had been leading in quality construction sometime. I don't know what's now, but I learned a lot from Iraq. I learned a lot from Qatar. I was in Libya also. I could not learn anything from there, because, of course, there was seriousness, but I did not find that level of seriousness. I'm not giving here plus and minus of some kind. What I'm saying is, everywhere, you learn something or you lose something. It's up to how you work, in what environment you work. My very question is, where do we have red lines? We have red lines everywhere, and can we coordinate? That's my question is, can we coordinate activities? Can we work on coordination activities to achieve defined or expected goals of quality? Or we have to change our profile of quality works? People should say. People should say, people refer to us, people should refer, oh, see this country, India, they are quality people. I did not hear anything as such. Can we work on coordination activities? My question was this. Can we coordinate to achieve defined or expected quality profiles? That question is very serious. And I would find, even if you answer yes, I won't believe it. I won't believe it because it doesn't exist. Therefore, my dear friends, we have to be very serious, and particularly those who are interested or are involved in quality, particularly engineers and professionals and engineering and other disciplines, other fields. Quality is a very big question mark, and if you want reputation in world, if you want something good in world, we have to care about this, or else we say we won't succeed in any issue of life. We have to think of all this, and it's very easy in fact if we are serious, and if we are not serious, it's impossible. It's not quality of material I'm talking about quality of work culture, quality of individuality, quality of confidence, and quality of experience. If you learn something which is bad, which is not to quality mark, then you will not learn quality. To start or to initiate whatever work, we cannot initiate work blindly. We have to first know what should be done. What should be done, what precautions we have to take in case we have to see certain problems. Problems, of course, would exist. We can't stop that. If we work, we shall find problems. Otherwise, there is no meaning of work. If no problem can come in that case, I can say it's same as you may say, I have been working for 10 years in this organization. I never made a mistake. I can't expect this. I can't accept this. If you work, you certainly would make mistakes because of human error or because of whatever else. If we say, no, I have not done anything wrong, then you are making a fake statement, I would simply say. And if you say, yes, I made mistakes, then you are a perfect professional because you accept something. And if you accept something, means you have a capacity to improve, to correct this. You have the capacity to apply remedial action on that. And that's a very important point. So if we can check ourselves, so self-improvement, self-checking, first we have to check ourselves. Then we have to think how to improve, and then we say, okay, I can apply this formula onto my own, and I am my self-investigator and self-corrector. In that capacity, until we cannot move. We may talk of whatever we want to talk. Self-investigation is best, self-correction is best. It teaches everybody. If I know what error I have done, I have caused, then I can correct it immediately without others noticing it at that moment. Why we should not revisit quality requirement specification? First of all, we have to revisit ourselves. Every professional has to revisit itself. We should not shy if we make mistakes. Everybody makes mistakes. Whole world makes mistakes, because mistakes are mistakes. We cannot avoid that. And mistake is not a crime. Yes, if you make mistake one time and you don't learn anything, and you make again mistake, again same mistake, in that case I can say you are not a professional, you are not a learner. You are learning, you have no learning capacity, you are a careless person, ignorant person. Quality visiting, I say revisit quality means first we have to visit ourselves again and again, and then we have to check our capacity of what can I do for other resources I'm going to use. And it's not easy, in fact. A chain, a sequence has to be constructed, formed, and that's what we can say seriousness. Seriousness means all points should be covered, and that too in sequence, one after other. Just like we chart out schedules for programs, we say, okay, do it, plan it. Plan means what? Plan doesn't mean we have to draw some lines and connect them like we do in rooms construction. This room, that room, or this area, that area. It's not that plan. It's a plan of something that you have to do, which we can't draw, but we can show by some indicators, and those indicators sometimes are Gantt bars, or if you use a CPM method or SPAT method or some other method, and that should be clear picture so everybody can understand this. Just like we draw that and we say this is our sequence of activities. In this we can say these are one activity is done after activity, and then we say these activities are independent of each other. We say dependent activities and independent activities. Then we find criticality, existence among them. And then we can say based on this we can complete this project, we follow this plan or schedule, and that is going to be implemented, goes to implementation, and we do it. Whether it may or not, it may not, it may be revised further, but at least we have certain baseline. We can say this is our basis, and our basis has not worked well, so we say okay, we revise it. That happens, and that should apply to everybody. We have to apply that to ourselves also. We have to make our own standards, our own working environment, our own. Even if you are one person alone, you have to chart out your own schedule, because schedule means your own design of time. How do you want to manage your organization, your time, and that time is yours, and you have no. Once you start that, believe me, you will change your startup. You won't say you got up early morning or whatever time you fix for getting rise, and it's okay. I have to maybe for a little variation, 5 minutes, 10 minutes, half an hour maybe. But when you have a chart, and this is your chart shall direct you. Your own design chart shall tell you, oh, you are here late, and grab and do it. You'll miss it, and then you can say every moment becomes important for you. And when every moment becomes important for you, this means you start valuing time, and time respects you. Then, oh, this person follows me, then time becomes good for you, your friend, and it tells you all time indirectly. Even maybe you forget, but because it's programmed in your mind through your conscious would vibrate you. Come on, God, this is happening. And that's where I think we should do. And if we can revisit ourselves, personal quality, individual quality, then we can say we can check others of which we work upon. And this practice, step by step, and particularly for those who are young people, who are students as well as who are learners, who are budding, it's important for them, because they are not very serious sometimes. They don't care for time, they don't care for quality. And then they cry on costs. The cost has become expensive, it's more expensive, you have to spend more. And you don't know that you wasted time, you did not care for that. You caused mistakes, and these mistakes would cost you something. And we can't claim that, and that's the point here. That's why I say profession is very different, and profession means advanced studies of whatever work we do. And that study can never end. It goes on telling you have to learn. So you say, why should we not? We revisit, we have to revisit, and we have to decide everything. And that revisit means a complete chain of activities and chain of applications of knowledge. And that should be timely, and that's what we can call it coordination. Coordination automatically comes in if you value time, if you value material, if you value theory, if you value, contracts, if you value your responsibility. Automatically you can say coordination comes in. Coordination demands something, and that what demands something is that you have to answer or you have to provide that. That's what I say. Coordination can be defined in many steps, in many ways. This is not perfect mechanism. It's your own mechanism. You have to operate it, and you have to operate yourself on this. You are a trainer, you are a track, and you are an operator, your guard, your driver, everything there. That point's important. And then we can say we can control, we can start controlling quality if we control ourselves. If I control myself, I can respect myself, I can assess myself, where do I stand, and when I start thinking about myself, in that case I shall think about work also. I can think about resources as well. It's not, it's profession, means profession. In profession, once you qualify, it's you who have to move on it. Nobody shall force you to move. If you move on it, you get on it. Of course, you cannot exclusively say, I am born only for this. You are born for this as well, I can say. Enjoy entertainment life and having good life, that's different. But seriousness does not mean, seriousness means you have to be you have to follow yourself first. You have to originate, you have to do original work and then follow it. And automatically it becomes a question one time, it becomes an answer also another time. Sometimes on step one you have started some question, you get some work on that and you get some answer of results of work, and that's number two, and then you can again go, there may be something on that number two and it becomes a question, and you have to go to number three for its result. Like that sequence is constituted, and that's very important point. So this one is a coordination, and that is a very important point in life. That's why I bring to your attention all the time. Coordination engineering projects, public and engineering is very important. Every day I show you same because I did not make any improvement on that. I don't have any improvement. So missing coordination means missing good engineering. Who wants to miss good engineering? Nobody shall like to miss good engineering, and particularly those who invest money and those who support them like engineers. Nobody wants to miss good engineering, but it happens even then. That's how I say our question, our considerations say that coordination is coordination engineering a must. That's a question mark. You have to answer yourself, is coordination engineering a must? And everybody says, sometimes I've seen many people say, I'm a coordinator. And what coordination means, they don't answer what coordination. See, there's a difference between coordination and liaison. I'm not talking of liaison. Liaison is a part of coordination. It's not a domain in itself. Or you can say sometimes people interact with each other and they consider this is coordination. No, that's not coordination. That is interaction. There's no difference because you're just coordinating others, or chatting with others, and sometimes talking of work. But that cannot be called coordination engineering because that's interactive engineering. Coordination is where information is required. You don't have information, you seek that information. When without that information is available, you cannot do anything. You cannot proceed further. Therefore, coordination is a technical term. It's an engineering term. It demands something. Every activity demands something. Every urgency demands something. We have to bring some information or many information at one place if those informations are required for some activity to move. And that information should come in time also. It's not that we get information now, I'll provide you later on this information. How can you then move this work? You cannot move that work. And that's where coordination has many orientations. It has many inputs, and it requires inputs instantly. It doesn't wait. And that's for coordination. It's a professional word. It's not simple word. Don't abuse it also. Once you start coordinating, once you have coordination means exactly solution program. You cannot solve yourself. You cannot solve anything. Don't abuse this word because liaison, information exchange, or just to know how should I do, that is not coordination. Coordination is different. It's a powerful word. It is used by top people. It's used by middle class people. I mean middle employees. It is used by everyone. Even the lowest employee coordinates sometime. And I say, what is project? And project means all performance activities involved from pre-design to final completion of complete construction, and it is complete string, very long string you can say. This means it includes pre-design stage, design stage, or you can say processing stage of work, how to work, whether work yourself or through contracts, and then construction and supervision itself, in which designs also move many times, and also then you can say installation is over, then you have to test and commission, or you have to whatever else, and then you put it into either occupation or in operation. So that is what project is. And when project is completed, means project term is temporary, it goes away. There's one date of start and there's one date of completion, or bring it to operation, and this period is called contract period of project period. And once it is over, then project term doesn't away. Therefore project is permanent, but for long time construction. There are many projects in your life, and those are projects. Being an engineer, you may have 10, 15, 20 projects in life, depending on length of projects. Sometimes you have hundreds of projects, depending on what, maybe very small projects likewise, you can say. And then there are many questions we can raise in these are. Engineering community has to answer itself, raise itself in what's quality and coordination, how you can define that in respective involvements in entirety, how these are applicable. Can we ignore these domains? That's the point. If you can ignore this, what shall you get? And what benefit you get if you ignore these domains? And benefit is no benefit. You can't ignore it. If you ignore this, you ignore yourself. You ignore your capacity, you ignore yourself, and that is very dangerous situation, you can say. You cannot ignore. So quality and coordination can't be ignored. These are respective involvements in the respective terms with each other. We can't ignore them. And therefore, so what do engineers think about issues as mentioned? Whatever you talked about working. What do you think about that? Do you think or not? If you think, what do you think? To what degree you think? Many questions come out. How many of us do conduct, how many of us do conduct works for quality and coordination engineering? It's not right time to contemplate and deliberate on this subject, because if you start quality work, believe me, if you care for quality, all world would change. If society cares for quality, if engineers think of quality, if workers think of quality, this is my first requirement. Just like in safety we say, I should be safe first. In safety domain, so it's the common domain, safety, health and environment. What do you say? First let me be safe, then I will start work. And it's right. I have to keep myself safe. I have to keep others, my colleagues safe, my workers, co-workers safe. I have to keep everyone safe, and then I start work. What's wrong with that? It doesn't mean you have to spend more time. Time is same. Only is conduct, how to conduct. Same way, in quality we can say, I have to start with quality. I have to move on with quality. I have to end with quality. And that quality is my own definition. It's not that somebody defined for me. It's already defined in work. It's defined what is normal, what is above normal. And that's we say, if we start doing quality work, we can change the entire scenario of society. Because if we believe in quality as engineers, engineering professionals, society would respect you, and of course they would rely on you. And when it happens, if engineers believe in quality and they do it, entire scenario would change, industry quality will change, factories work would change, construction quality would change. And when you force quality to change, you shall have that level of those contractors, those people who come to you for business like this. They would change because they know there are people who can check and they won't accept our work if it doesn't go with quality. And in what happens if that stage comes, then it's not only you and public think, then it reaches to top level, it reaches to political level, government level. And then government also starts thinking that people have changed, people won't trust our bad quality activities or bad work plans, then they will plan also accordingly. And that's what I say, quality is like a body respiration. Quality is like body respiration. We respire, we breathe, and we survive. And if I stop breathing, I can't survive. Same way, but because quality cannot speak, work cannot speak, work becomes useless only, that's all. You produce quality work, maybe it performs to some extent, not to full extent that you intended it to work for. That's why how many of us are serious? We have to find ourselves. If you don't do this, we won't be respected at international level as well. And we have been respected because maybe we are not sure about that, but when we adopt to those situations, when we work overseas, we are respected, we are honored as far as work is concerned. It doesn't mean that they gift or they issue some awards. Question is, they employ you, they rely upon you, and that's best award. I don't believe in any award. I believe in confidence. I believe in people trust you. If people trust you, and if those people who don't belong to your country, they trust you, that is best award. That's best winning. That Indians so good engineers, very good engineers. We say Indian engineers very good. Oh no, he is Indian engineer. He shall do this. That confidence level, that trust level is real award. I don't need these citations and this. You have to award yourself, and that award is good work, quality work. It's not right time to contemplate and deliberate on this. This exactly every time is right time. Even if you are a quality country, you have to improve it. Plan, do, check and improve. We generally call it plan it, do it, check it, correct it. Can good industrial practice be achieved? That's the answer for that. Can good industrial practice be achieved? Yes, we have to achieve without moving through quality and coordination domain. Can we achieve it? No. We have to first achieve safety, we have to achieve quality, we have to achieve before quality coordination, because when quality is achieved, this means coordination works. Can engineers' design be reliably carried out without involving quality and coordination? I would say never. We can never do that. We do only work, okay, let it go on, we will see next time. That tendency is worst. When I say we'll see next time, no, we have to see this time. Time is time. And if we raise ourselves to that status, everybody shall be concerned about that. If you want to change society, if you want to change these people who want to make money, you have to be strong, you have to be in that level. The people start thinking, no, I can't do anything, because these expert people, they want everything to requirement. And that is point where we can see start developing. I call that is development, nothing else. You have to develop yourself, you have to develop works, you have to develop products, and you have to sell them. And if your product cover itself under quality, if your product covers itself under quality, it shall be demanded by internationals, and you will become industrialized country. Otherwise, you're not. But where are we going to? We have to decide ourselves, and that's an important point. Where we're going to. And we're talking about items of concrete last time. Of course, it's very important. We have covered many pages on this, and water tightness we are talking, and we are talking what constituent materials, cement, etc. We talked about mixing water. I think we talked about this, right? And also aggregates, fine aggregates. On this page, I think we did not talk, so we have to go to. We start here mixing water. Ultra rapid hardening, I think we have done this one. Blast furnace slag, we have done this. Type B. Let us see. Cement, let us start. I think this chapter constituent materials, as we talked about. Factory physically. Think it is. Let us say this for start. Let us repeat this. Yeah. It says cement, which is appropriate cement, shall be selected according to intended use, and that's true. And cement shall also comply with requirements. All right. When cement other than types of cement mentioned, so shall be ascertained that performance requirements of concrete are met. Performance requirements of concrete are met. That's true. Now, what commentary says it is. Let's come into here is, let me put off my switch of battery so that it keeps on working, and let's see how does it work. And let's put a battery also. Weather conditions, time and duration of construction, and I think we should keep something here. Duration of construction. It's necessary to select most appropriate cement for construction by considering type, size, and location of structures, weather conditions, time, and duration of construction procedures, and to produce concrete that require performance steadily and economically. Types of cement specified include normal high early strength, very high early strength, moderate heat, low heat, and sulfate resistant Portland cement. Portland cement, blended cement conforming to whatever Portland, blast furnace slag cement, Portland pozzolana cement, Portland fly ash, and cement conforming to this eco cement. I think we have gone to this eco cement in many projects. Normally Normal Portland cement is used. Other widely used types of cements include high early strength and moderate heat cement in or Portland cement, and blast furnace slag cement and fly ash cement. And blended cement is being expected to contribute to realization of zero waste society. That is, today cement is being expected to contribute to realization of a zero waste society, or by making it possible to reuse byproducts from other industries in 2003 in order to meet the growing demand of industrial byproducts that can be used as materials for normal Portland cement. Allowing upper limit for the chloride ion content was raised from 0.0 to 0.035%. I think we have gone through this. In general use of high early strength Portland cement in a low temperature environment decreases degree of decay. Use of high early strength Portland cement in a low temperature environment decreases degree of delay in strength development at early management. Where the low temperature, you can say high early strength Portland cement is a good one. And in case of low temperature curing, thereby making concrete less susceptible to damage by freeze-thaw cycles. Use of high early strength Portland cement in a high temperature environment, in contrast, contributes to rise in concrete more difficult because of stiffness of concrete resulting from high temperature and making concrete more prone to cracking in high temperature environment. Therefore, it's desirable the moderate heat or normal Portland cement or type B blended cement be used so as to reduce amount of concrete temperature rise and subsequent cracking due to temperature fall. Type B blast furnace slag cement is effective in reducing alkali silica reaction. That's type B blast furnace slag cement is effective in reducing alkali silica reaction and chloride infiltration. And type B blast furnace slag cement in recent years, however, tends to be formulated so that depends on slag content, powder content, you can say. Initial strength between high, consequently high initial, you can say initial strength becomes high in case of that cement as a type B blast furnace slag cement in recent years. However, tends to be formulated so that depending on slag content, powder content, that is initial strength becomes high, and consequently there are cases where adiabatic temperature rise rate of concrete is higher than that of normal Portland cement. There are cases where adiabatic temperature rise rate of concrete is higher, and let me also see for explanation what you're talking, and that's important point here. That is here. Let me just a minute, please. Let me explain also that one. Concrete temperature. Let's see. Let's start. Let's Google your. This concrete. I waste time sometimes. I know concrete. Adiabatic. I just want to clear now itself. It's the adiabatic temperature of all specimens adiabatic temperature of all specimens converges in 2 days after concrete placement. Generally, it's reported that converging with time of maximum adiabatic temperature by adiabatic temperature rise, it takes 5 and 7 days. Just a minute. It's not giving me that answer which I'm expecting. A study of adiabatic temperature rise of saturation, that is properties of the temperature rise of concrete, the properties of adiabatic temperature rise on concrete. What does it say? Are you opening? Yes, there's some file opening, and I'll read this for you because it's PDF, I think. So you will see this also, this PDF file, and it's 9 pages. Let me see what it says. But understand this point also very important. Yeah, understanding is more important than just running away. So it says Indian Journal of Engineering and Material Science. So this is our journal. So there should be no problem in understanding it. It says properties of adiabatic temperature rise. I think you can see this file here. It says properties of adiabatic temperature rise on concrete consideration, cement content and setting time, and this is received on 31st October 2013, and this is A hydration heat of concrete. Hydration heat is talking, is abstract. I'm just reading. Hydration heat of concrete is closely related to thermal stress and crack. Let's go through what actually total it is there, how many pages are there, what's written there. Can we go through jump, just move in that, just understand that. We have to understand this also parallel to what we're talking of, and it's adiabatic rise I'm talking, what does it mean, and it should be clear. I don't think it's big, so we can just have a look on this. You can browse on this, and I think that's a good one. Let me first save this. It's also important to save, and it should be, I think it's coming out. It's coming out, not it's coming out. So this is concrete. This is what? It is UEMS. This is book facilities on shore. So this is concrete. I can say concrete and adiabatic. I may say adiabatic. I'll just save it now, and we'll. That's okay. All right. Now what it says is, again I read. And that is hydration heat of concrete is hydration heat of concrete is closely related. It's closely related. It's not working. I have to back come to hydration heat of concrete is closely related. I think it's said now, right, to thermal stress and crack. An adiabatic temperature rise test is a typical method for measuring hydration heat. Aim of this study is to investigate effect of cement content and placing temperature on adiabatic temperature rise of concrete. To investigate behavior of adiabatic temperature rise of concrete, it was decided to set binder content taking into account mixing temperature of concrete and placing temperature of concrete that are 25 degrees Celsius and 35 degrees Celsius respectively. And again it says investigate, how to investigate behavior of adiabatic temperature rise of concrete. It was decided to set binder content taking into account mixing temperature of concrete and placing temperature of concrete. Mixing temperature of concrete is 25 degrees Celsius and placing temperature of concrete is 35 degrees Celsius. That's one part of this story, and I think and then I'll just a minute please, let me see also one more point, what we call in for everybody to understand adiabatic. What is adiabatic in Hindi? I do not know. Maybe I get this answer. Adiabatic is not given in Hindi anyhow. It's given thermodynamics and adiabatic process. In thermodynamics, in heat engineering, you can say in thermodynamics and adiabatic process, it is just impossible. Impossible is a type of thermodynamic process that occurs without transferring heat or mass between thermodynamic system and environment. Says impossible, that cannot pass, is a type of thermodynamic process that occurs without transferring heat or mass between thermodynamic system and environment. And in thermodynamics, an adiabatic process is a type of thermodynamic process that occurs without transferring heat or mass between thermodynamic system and environment. Unlike isothermal process, an adiabatic process transfers energy to surroundings only as work. So that's what it says. And thermodynamics change occurring in a system as a result of transfer of energy to and from system in form of work only. Adiabatic process is one in which no heat is gained or lost by system. So no gain of heat or no loss of heat. First law of thermodynamics with Q is equal to 0. Okay, so this we understand, no transfer of heat. So that's what it says. What we say that to investigate behavior, you can say investigate behavior of adiabatic temperature rise of concrete. It was decided to set binder content taking into account mixing temperature of concrete and placing temperature. Mixing temperature at 25 degrees Celsius and and placing temperature 35 degrees Celsius respectively. It said cement content has a linear relation with maximum value of adiabatic temperature rise, and that is K, adiabatic temperature rise, and reaction factor R. Temperature rising ratio of specimen with placing temperature 35 degrees Celsius rapidly increase compared to that of specimen with placing temperature 25 degrees Celsius. This means higher temperature plus 35 degrees, it increased rapidly in comparison to lower temperature 25 degrees Celsius. But maximum value of adiabatic temperature rise between placing temperature 25 degrees Celsius and 35 degrees Celsius not significantly different. Furthermore, it's found that starting time of hydration heat after placement of concrete has a high correlation with final setting time. It's necessary to analyze effect of adiabatic temperature rise by taking final setting time into considerations. So here is now coming back to detailed discussion. Generally, concrete experiences a significant amount of hydration heat during cement hydration reaction. Let's start immediately when cement is mixed with water, and we know all that. Though hydration heat is observed in all types of concrete, it can be particularly high in high performance concrete having low water to binder ratio. Hydration heat of cement can lead to surface breaking cracks. Hydration heat of cement can lead to surface breaking cracks when base friction or other restraints occur. Presence of surface breaking cracks in concrete structures may not necessarily imply structural failures, but may cause various durability and serviceability issues, namely stiffness reduction, infiltration of water or deleterious materials, corrosion of reinforcing steels, which may finally lead to early malfunction of concrete structures. That's why hydration heat of concrete is an important design issue. Effective cooling methods should be developed to avoid damage induced by temperature cracks. Other major causes for high hydration heat of concrete is temperature of surrounding environment. A high environment temperature leads to high placing temperature. High environment temperature leads to high placing temperature. High placing temperature causes maximum temperature rise and leads temperature rising velocity of concrete at early age. It increases possibility of occurrence of cracks in concrete. In Korea, when average temperature exceeds 25 degrees Celsius, use of hot weather concrete is recommended. It is in Korea at 25 degrees temperature. Use of high weather concrete is recommended, and placing temperature is limited to 35 degrees Celsius. It's important to predict and manage hydration heat of concrete in advance by considering environment temperature and or placing temperature. Research in field of material science have made great efforts to find an effective reduction method of hydration heat of concrete. Reduction of hydration heat of concrete is achieved by 4 methods. That is what we have to achieve. Reduction of hydration heat of concrete achievement is done by 4 methods. Let's see what are those. Post cooling of concrete structure. Post cooling of concrete structures. Post cooling means you have to cool after. The water pipe cooling is now widely adopted to control temperature of damp concrete, and that is in dams. We say water pipe cooling is now widely adopted to control temperature of dam concrete. However, large temperature difference between water and concrete causes large temperature stresses. Large temperature difference between water and concrete causes large temperature stresses around cooling pipe, and this may result in serious cracks which are harmful for concrete structure. Pre-cooling of concrete materials. Pre-cooling of concrete materials, that is what we say, pre-cooling of concrete materials. First use of pre-cooling of concrete materials to reduce maximum temperature of concrete was by corps of engineers during construction of New Fork Dam in early 1940s. Part of mixing water was introduced into concrete mixture as crushed ice so that temperature in place fresh concrete was limited to about 6 degrees Celsius. Recently, pre-cooling methods such as aggregate cooling by spraying liquid nitrogen. Recently, pre-cooling methods such as aggregate cooling by spraying liquid nitrogen on concrete after mixing. So pre-cooling is methods such as aggregate cooling by spraying liquid nitrogen on aggregate, and spraying liquid nitrogen on concrete after mixing. Vacuum cooling of aggregate by evaporation heat. Vacuum cooling of aggregate by evaporation heat, and mixing water with cold water or ice are being adopted. Use of smart materials, namely phase change materials. Phase change materials or setting retarders. Since 1990s, many works have been carried out to reduce interior temperature rise of mass concrete with PCM. Some researchers found that after PCM was blended with cement, pozzolana, P stands for pozzolana, just for pozzolana containing cementing material. So temperature peak was reduced and appearance time of temperature peak was delayed. What it says, some researchers found that after PCM was blended with cement, pozzolana, temperature peak was reduced and appearance time of temperature peak was delayed. However, strength of concrete was also decreased. Meanwhile, using a setting retarder is an effective way to reduce temperature peak. Meanwhile, using a setting retarder is an effective way to reduce temperature peak or temperature rise velocity by retarding hydration reaction of cement or reaction velocity. Recently, research and development of micro encapsulated retarders. For achieving stepwise setting retard effect is gaining traction. This is micro encapsulated retarders for achieving stepwise setting retard effect is gaining traction. Replacing normal Portland cement with other cementitious additions, that is, you can say namely fly ash or blast furnace slag. Technical advantages of using fly ash and slag concrete compared to plain PC concrete relate to low heat of hydration, which is of particular importance in case of massive concrete elements, increased durability of reinforced concrete in marine environment, and increased long-term strength. A study by this is Westbelka, showed that some of positive characters of slag concrete can be obtained by even at replacement level as low as 10 or 20%. Adiabatic temperature rise test is carried out to estimate hydration property of concrete. That is adiabatic temperature rise. Adiabatic temperature rise test is carried out to estimate hydration property of concrete. Result obtained on basis of adiabatic temperature rise is given herein. Q is equal to K bracket 1 minus e to power minus RT, where Q is adiabatic temperature rise at HT degrees Celsius, K is maximum amount of adiabatic temperature and rise, that is degrees Celsius, is then R is reaction factor degrees Celsius per hour, and T is age days, and T naught is starting time of hydration heat in number of days. That's only formula. What it says here that is, we can see that here. I'm talking this adiabatic temperature rise history varies according to mix of concrete. However, we'll refer to figure. However, result of comprehensive analysis of reaction factor and the adiabatic temperature rise is insufficient. Study consistently sets unit water content and amount of binders to review properties of adiabatic temperature rise of high strength concrete on amount of cement as well as types of replacements, rates of admixtures. Consider effects of environment temperature on hydration temperature. Adiabatic temperature test of concrete was carried out setting placing temperature and initial curing temperature 25 and 35. So this is adiabatic temperature test of concrete was carried out at setting of placing concrete temperature 25 degrees and initial curing temperature 35 degrees. So this is rise, that's why initial 25 and you can say initial curing temperature 35 and placing temperature is 25. In addition, relation between starting time of hydration, heat and setting time is investigated to analyze adiabatic temperature rise equation with respect to amount of cement. Now here's a curve, you can see age here, and this is adiabatic temperature rise in degrees Celsius, and here is red line adiabatic temperature rise history according to experiment, and this is Q is equal to, that is adiabatic temperature rise. Here is this equation, and this maximum value of the adiabatic temperature rise K. And same way, if you say a schematic of adiabatic temperature rise by various factors, and there is this one, you see mix of FA or BFS, blast furnace slag, decrease of hydration, heat and velocity, rise of placing temperature here, and this is for this purpose, schematic of adiabatic temperature rise by various factors. Now we go to have this table, experimental plan. What was that? Let us study this. One is ID, other is WB, water, cement and blast ratio, I think, and then that is unit binder. What is that? How much is that? And after that SF, then replacement, how much replacement was there, and BSF. SF is silica fumes, and FA is fly ash, and BFA is blast furnace slag, and placing temperature. This is required table. It says that WB, water, WB, that is water quantity to your cementitious quantity or OPC. Here is what 40, it is 40 water, this percent is 40, and this OPC, unit of OPC kilogram per is, that is only 400, In that case, there is no data because no SFE, no FE, no ABS. The placing temperature was 25 degrees Celsius plus minus 1 degree Celsius. And then in case of 34, we come down from 40 to 34. It increased, here it is 470.6 binder increased because, and of course there's no indication of temperature rise here. I don't know, it should be more, but it's not given then. In case of 29, and we got, in case of 29 OPC, we got further increase up to 551.7. Of course, silica fume is there, 5 and nothing else data. Then 39 F220, you can say here also silica fume is 5 and 20 is replacement. Same way you can say. And the case of 35 one, it's not shown in here. Then 40 and 70, something is silica. If you take here with this, as for there are few cases of shown 5 cases of silica fume, and out of those 5, 2 are having replacement of fly ash, and in BSF there's only 2 at end. So what it says ultimately here is silica fume is called microsilica in fact, and fly ash FA and BF is blast furnace slag powder. Now water over B or WB, water cement each material ratio as usual. So here it is in F20 case, that is F20 case binders with OPC 80% plus fly ash 20%, and that is 20%, 20 given there. Means F20 is binder with OPC 80% and fly ash 20%. In case of F35, it's fly ash 35, 65% is OPC and 35% fly ash. S40 binder with OPC 60%, blast furnace slag 40%, and also the case is blast furnace slag 70%. So that's what still saying now. So mixing of concrete, what does it say? Also almost same what it says. WB40, 30 same sequences here, and you can see WB ratio up to 29. W29 is the less. First is in the case of 40 WBS, and then 34, then 29. Silica assay is assay. What is the assay? Not given about. Assay sand percentage. As I say. Sand percentage, as we see how many hours have gone. This is 1 hour 12 minutes. So let us say, so its assay is sand percentage, W is water, C is cement, G is coarse aggregate, S is fine aggregate, and table says this, W is water, 160, you can say 160 kilogram. Here WB ratio is 40, 39, 39, sand percentage 43, 48, 44. Usually we take when call calculating manually, we take 45 sand. I think 42, yes, 42 sand we take, generally almost same. And 84 we take aggregate. Let's see now what it says is 160 all cases, that is water, and cement quantity in 40 is 400, and 3 SAM 470, 524. Likewise, you can say, and ultimately it goes down in case of 29, and when you are using from 29 onwards, it goes down to at F29, F20 is for 13, 35, 30, like this. And then silica fume issue is from case of, you can say here, that is silica fumes. The silica fumes here 27, and fly ash is in 2 cases shown, while BFS case in at end 2, and we can say G, that is coarse aggregate, quantity is given largest in W40 and goes down up to 870, and you may see there's about 50 difference, or you can say 35 difference, 15 plus 25, 40 approximately 40. Then also, similarly it goes down, and also fine aggregate, and goes on. You may see these differences here, and also water's SP is percentage is 0.6, goes on increasing in other cases and comes down, as in last two cases of you can say BFS and SFS. So experimental procedure, what does it say? Test specimen and material properties. Test specimen and material properties. Test specimens made, test specimen made from high strength concrete were prepared. Test specimen made from high strength concrete were prepared in laboratory. High strength concrete was made from mixing proportions having 29, 34 and 40% water to binder ratio, and for 400, 470 and 551 kilogram per meter cube cement. Specifications of mixing proportions are summarized. Now we have seen that main variable of experiments in this case is water cement ratio, cement material ratio 40, 34, 29. Replacement ratio of mineral admixtures fly ash is 20 and 35% of total binder weight. Blast furnace slag powder 40% and 70% of total binder weight. And placing temperatures 25 degrees Celsius and 35 degrees Celsius. In addition, 5% silica fume was mixed for developing compression strength in water cement with 29% concrete mixture. Now, materials, that is materials of concrete used in this study are ordinary Portland cement, density 3.15 gram per cube, fineness 3770 centimeter square per gram, 3770, that is fineness of Portland cement. Desalting sand, that is density 2.54 gram per cm cube, fineness modulus 3.05, absorption ratio 1.01, crust aggregate density 2.65 gram per centimeter cube, fineness modulus 6.02, absorption ratio 1.39, silica fume density 2.5 gram per centimeter cube, fineness is 200,000 centimeter square per gram, and that is for silica fume. And it's a very important point, many times finer than cement itself. That is fineness. 2.2 gram per centimeter cube, that is for fly ash, and we have fineness of silica fume just 2.5 gram per centimeter cube with fineness 200,000 centimeter square per gram, while fly ash is 2.2 gram per centimeter cube, its fineness is 3,000 centimeter square per gram, much lower than silica fumes. Silica fumes is 200,000 centimeter square per gram. There is a lot difference in this. Blast furnace slag powder density 2.91 is heaviest, I think 2.91 gram per centimeter cube, and fineness is 400,000 centimeter square per gram. Means BFA, it was, you can say, it was 200,000 centimeter square fineness for silica fume, while fineness for is your fly ash 3,000 gram per centimeter square. Blast furnace slag is 2.91 gram per centimeter cube, fineness 4,000 centimeter square, and high range water reducers polycarbo but not that complicated. You can understand. It's very important. I got by chance and this it included into this talk because of that. In this study, you may say slump flow, air content, and setting time were tested in accordance with ASTM C161 standard test method for slump flow of self-consolidating concrete. Self-consolidated, that is, standard test method for slump flow of self-consolidating concrete. Now, ASTM standard C231M test method for air content of fresh concrete by pressure method, and ASTM C403M standard test methods for time of setting of concrete mixtures by penetration resistance, respectively, to investigate effects of placing temperature and mineral admixture on early age properties of concrete. In this study, a superplasticizer was added as a supplement to make sure minimum fluidity target slump flow for 600 plus minus 50 mm. This is target slump 600 plus minus 550 mm of fresh concrete. Adiabatic temperature rise simple. I'm 600 saying slump flow, not fall. It's slump flow means it flows a lot. So means it is self compacting 600 mm plus minus 50 mm. It's flow, horizontal flow. Adiabatic temperature rise is what test it is. That is adiabatic temperature rise. Temperature of used material to satisfy mixing temperature requirements of concrete. Temperature of used material to satisfy mixing temperature requirements of concrete, and was calculated. And this equation is here, you can see yourself, means I'm not going to talk on this much. TA stands for temperature of aggregate and TC stands for temperature of cement. Temperature of aggregate, temperature of cement, and TW is temperature of water. WA is dry eroded weight of aggregate. WC is dry eroded weight of cement, and WW is dry reduced weight of water, and WWA is absorption ratio of aggregate. Concrete, that here you can see formula 0.22, and TAWA, TCWC plus of that, and TWW and TAWA. All this sum equation divided by 0.22 WA plus WC. Likewise, you can think of that as test adiabatic temperature rise. What it says now, concrete that reached target temperature was placed on adiabatic temperature rise test device after mixing. Adiabatic temperature on concrete specimen was monitored by using a thermocouple. Adiabatic temperature rise in concrete. Adiabatic temperature in concrete specimen was monitored by using a thermocouple. Measurements were taken at intervals of 10 minutes until internal temperature conversed. Volume of mold specimen was 50 liters. Now result and discussion. Fresh concrete, what does it say? It's a serious issue today I'm talking of. It was observed that water cementic material ratio and mineral admixture affect early age properties of concrete such as setting time, slump flow, and air content. First, role of water binder increase, water binder percent increase, and mineral admixture replacement ratio was demonstrated to be effective for delaying initial and final setting times. So the water binder ratio increases and mineral admixture replacement ratio was demonstrated to be effective for delaying initial and final setting times. In concrete specimen with 34 and 40% of water binder ratio, setting time were delayed by approximately half an hour compared to that in a specimen with 29% of WB. Alright, so in accordance, you can say, if you see show figure, you see figure later on, just now in case. In concrete specimen, 34 and 40% of WB water binder. Setting time were delayed by approximately half an hour compared to specimen with 29% WB. Furthermore, delaying effect by using fly ash, and blast furnace slag significantly increased as replacement ratio of mineral admixture increase size. Furthermore, delaying effect by using fly ash and blast furnace slag significantly increased replacement ratio of mineral admixture, especially in concrete specimen. 70% with 70% blast furnace slag setting times were delayed by about 8 hours compared to specimen of OPC water binder ratio 29%. In contrast, accident effects on setting time was observed as placing temperature was increased from 25 degrees to 35 degrees Celsius. In addition, it is found that slump flow tends to increase with increase of amount of fly ash. The slump flow tends to increase with increased amount of fly ash and blast furnace slag in concrete specimen. Accordingly, amount of superplasticizer to meet target slump flow requirement decreases. And this phenomenon can be explained by ball bearing effect. Ball bearing effect observed as fly ash consists of spherical particles. However, effect of fluidity by BFS particles is due to another cause. Fluidity of concrete is associated with morphological characters of BFS particles. Fluidity of concrete is associated with morphological characters of BFS particles. At initial stage of cement hydration, BFS particles are packed uniformly on surface of cement particles. At initial stage of cement hydration, BFS particles, blast furnace slag particles are packed uniformly on surface of cement particles, which retard and decrease mutual combination of early hydration process products. Now, this is sometimes somewhat similar to effect of water reducers and increases fluidity of mortar. In other words, glass of Si2 constituents BFS particles and reduce frictional force among particles. In other words, glass of Si2O2 constitutes BFS particles that reduce frictional force among particles. A smoother surface of particles, better was fluidity of mortar. Next, air content tends to decrease with increase of amount of mineral admixtures. Air contents tends to decrease with increase of amount of mineral admixture. However, variability Variability of air content does not appear to have a significant impact on performance of concrete. Adiabatic temperature of concrete. As a figure shows adiabatic temperature in concrete with respect to water binder and amount of mixtures. Placing temperature was set to 25 degrees Celsius and 35 degrees Celsius. Adiabatic temperature of all specimen covered converts in 2 days after concrete placement. As a graphics you can see placing temperatures 25 and 35, 25, 35. So this is same time repetition in many classes, and its setting time is upwards. So you can say in every case of from 40, 34, 29 to down, we can say what happens to OPC, F20, F35, S40, 70, and we can see that there is it is a case of setting time. In first case WB40 OPC, setting times 4 to 6 point something hours, and also this is here if you say final set, that is square. Final set and initial set is triangle, so triangle to triangle and square to square. In first case it is 4 to 6 hours in case of initial set, but final set is 6 to 8 hours when it is OPC only. And same thing applies to all OPC issues in first three cases. And when it is 29, it's little low. It is low, and also in case of before that 34s. But we can go to fly ash, F20, fly ash. In this case, triangle is up. That is initial set is also a little delayed, and your final setting. That is final setting is also delayed. Same happens in F35. Of course, little difference, and also in case of 40, you may say in triangle of this setting time above little, and also in case of you can see differences. And when you come to 2970, 70% replacement of slag and 40% slags, and 70, you can see it's skyrocketing. 6 to 10 hours, so 6 to 10 hours approximately for initial setting time, and 8 to 18 hours in that case. So this is setting time by mixing conditions and placing temperature. Now we go to age days, and there's another one, adiabatic temperature rise, and there are cases showing in age days 0.2 and then 2.5 to 2. It's only for 2 days showing. Let's just watch works in adiabatic temperature rise in concrete. Spines is not difficult to understand here. There's days up to 2 and 0.5, 1 and a part 2. Adiabatic temperature rise in degrees, and up to 90 is given. We can say 0 day, no use. It goes to few hours only. Placing temperature, and that's here 20 and 30 in between, 25 approximately. And then it is maximum temperature curve, blue, 68.6 degrees. If you take W40, and so please now check to have this. It goes increasing, and in this blue line it is your adiabatic temperature rises. If you take red one, that's 34 OPC, 75%, 80 Celsius, and then you get the other one. So this temperature rise is very clear from these equations, these graphics. Adiabatic temperature history, temperature rise history. Generally it's reported that you can say sorry gentlemen, it's reported that convergence time, let me check my battery, It's 349, so I have to wait a little, otherwise it closes down itself. It's reported, generally reported that convergence time of maximum adiabatic temperature by adiabatic temperature rise takes between 5 and 7 days. In this study, however, the phenomenon that convergence time decreases by use of high strength concrete was confirmed. It was observed that increasing water binder and using admixture is also that increase in WN using admixture tend to decrease what says temperature, maximum adiabatic temperature that's using admixture tend to decrease maximum adiabatic temperature and temperature rising velocity at early ages. For the specimen with placing temperature 25 degrees Celsius, a measured maximum adiabatic temperature was value of WB34 minus OPC and WB40 minus OPC was 75.8 degrees Celsius and 68.6 degrees Celsius respectively, which were reduced by approximately 3.7% and 12.9% compared to what this one, the time of C 78.7 C. Furthermore, maximum adiabatic temperature value of WB29 minus F20 and this other one and all these were reduced to by temperature 9.6 degrees, 12.2 degrees, 12.9 degrees respectively, and 32% compared to that of 29 points OPC. Similarly, in a specimen with placing temperature 35 degrees Celsius, it's confirmed that increase of water pointer and use of admixture led to decrease of maximum adiabatic temperature values of concrete. In addition, maximum adiabatic temperature of all specimen with placing temperature 35 degrees was within 60.5 degrees and 89.1 plus 1 degree Celsius. This was in addition, maximum adiabatic temperature of all specimen with placing temperature 35 was between 60.5 degrees Celsius and 89.1 degrees Celsius, which were increased by approximately 9% to 14.9% compared to that of 20 WB29 SOPC with placing temperature 25 degrees Celsius. In other words, placing temperature is an important factor that has a significant effect on rise of adiabatic temperature. Now this figure shows relationship between the current content and maximum adiabatic temperature in concrete. That's figure 4. We'll see that one. Let me finish this. It was found that a linear relationship exists between maximum adiabatic temperature and cement content. It means cement content exclusive of amount of mixture in concrete contributes to maximum temperature. There is a curve that cement contents up to 600 kilogram at a cap of 100, and the maximum temperature rise up to 60 and 80. That's ambient temperature says. Placing temperature 25 degrees Celsius and y is equal to what's y is equal to placing temperature, and that is y is equal to 0.0618 plus 46.242, r is equal to 0.9232, and here is y is equal to this value plus 51.774. Here in this equation you can say this is y is equal to 0.0618x and 46 to the power 4 and r square. Now this relation between cement content and maximum temperature in concrete, and here is increased by approximately this quantity compared to this much with placing temperatures. In other words, placing temperature on rise of adiabatic temperature. Figure 4 shows the relationship between cement content and maximum adiabatic temperature in concrete. It was found that a linear relationship exists between maximum adiabatic temperature. So hot, huh? It was found that a linear relationship exists between maximum adiabatic temperature and cement content. It means that cement content exclusive of amount of admixture in concrete contributes to maximum temperature. The various you can say rises here. This is, and WS40 minus OPC, temperature 25, WS29 OPC, and W29 S40. You can say S431 for 551. That's very important point. Placing temperature 35, and 35 again 35, and this. Now there's another one, and that's adiabatic temperature rise in temperature rise ratio. Temperature rising ratio, so the adiabatic temperature rise and pressure rise ratio. And before that, I put on it. I want to actually finish this before going to for 5 minutes. This figure shows adiabatic temperature rise according to this figure 5 talking of above figure, not this one. This is the figure talking of. This figure 5 shows adiabatic temperature rise according to concrete mix and the placing temperature. It was found that temperature rising ratio with placing temperature 5 degrees Celsius in a day was higher than of specimen with placing temperature 25 degrees Celsius. On the other hand, adiabatic temperature rise of all specimens with placing temperature 35 degrees was lower than that of specimens with placing temperature 35 degrees Celsius compared to tendency of a maximum adiabatic temperature. In concrete, hydration reaction in early ages is activated. Hydration in concrete, adiabatic temperature rise decreases. It can be explained by adverse effects of high early temperature that Verbeck and Helmut suggested. Let me put it on, otherwise I'll forget. It's hotter today, 25 degrees Celsius. This time 25 degrees Celsius is hotter. So we can say again, adiabatic temperature rise, as I said, adiabatic temperature rise of all specimens of placing temperature 35 was lower than that of specimen placing temperature 25 degrees Celsius. It says temperature on concrete. Hydration reaction in early ages is activated as placing temperature concrete increases, although inactive hydration reaction increases with temperature rise ratio in concrete. adiabatic temperature rise decreases. So says this figure shows adiabatic temperature rise according to concrete mix and placing temperature. The temperature rising ratio with placing temperature 35 degrees in a day was higher than that of a specimen with placing temperature 25 degrees. Adiabatic temperature rise of all specimens with placing temperature 45 degrees was lower than that of a specimen with placing temperature 25 degrees compared to tendency of maximum adiabatic temperature concrete. Hydration reaction in early ages is activated as placing temperature concrete increases. Although inactive, hydration reaction increases, although temperature rise ratio in concrete. In adiabatic temperature rise decreases, it can be explained by adverse effects of a high early temperature, and Warbeck and Helmuth suggested. According to them, rapid initial rate of hydration at high temperature retards subsequent hydration. According to them, rapid initial rate of hydration at high temperatures retards subsequent hydration and produces a non-uniform distribution of products of hydration within paste. The reason for this is that at high initial rate of hydration, there is insufficient time available for diffusion of products of hydration away from cement particles and for a uniform precipitation in interstitial spaces. As a result, a high concentration of product hydration is built up in vicinity of hydrating particles, and this retards subsequent hydration. Therefore, hydration reaction of cement particles cannot be completely proportionally, and this has negative effects of long-term strength of concrete. Now this figure 6, which is there 6 division of adiabatic temperature rise, and we can say test results, the red line equation here 0, that is age and adiabatic rise in temperature, the W29 minus OPC and 40 minus OPC equation. Analysis of adiabatic temperature rise in history, and was the adiabatic temperature rise history. Now this figure, the adiabatic rise history is divided into 3 sections. Hydration heat almost cannot be seen in section. Generally, hydration heat in concrete tends to begin in a short space of time after placement. To reproduce an accurate adiabatic temperature rise history, time of section needs to be clear in this study. Considerations 0 equation was modified to equation 3. So let us see how many minutes I have. 1:48. So it is here. Okay. It says you can see this here. This is test results, and this is WB 40 minus OPC, WB 29 minus OP, section 1, section 3. Which stays in these divisions. Adiabatic temperature rise history is divided into 3 sections. Hydration heat almost cannot be seen in section 1. In section 1, hydration heat is not seen here. That's what's very small. Here is big one, and there's little flat here in section 3. And but then it says, in fact, I'm sorry, I've gone wrong way. Let me see, and this is here. So In fact, is as shown as this. So adiabatic temperature rise is divided into three sections. Hydration heat almost cannot be seen. One, general heat hydration tends to begin in short space of time after placement. To reproduce an accurate adiabatic temperature rise history with time T naught of section 1 needs to be clear in this study. Considering T naught of section 1 was non-modified to equation 3, and that's this one, Q is equal to K to 1 minus E to power minus 2 by R to T minus T naught. It gives adiabatic temperature rise at T degrees Celsius. K is the maximum value of adiabatic temperature rise. R is but it is considered that ignoring temperature rise in section 1 is effective to increase the reliability of reaction stack factor of R. Now, a relationship between, let us consider that ignoring temperature rise in section 1 is effective to increase the reliability of reaction factor R. Relationship between time of section, relationship between time T naught of section 1 and setting time was analyzed. Temperature increases rapidly in section 2 of adiabatic temperature rise history. This section is linked to reaction factor, a constant. In addition, since behavior is behavior of concrete within a day, so say relationship between temperature time of section and 1 and setting time was analyzed. Temperature increases rapidly in his section 2 of adiabatic temperature rise history. This section is linked to reaction factor. In addition, this behavior of concrete within days concluded that reaction factor is related to placing temperature of early stages. Lastly, temperature coverage in section temperature converges in section 3. Temperature started from placing temperature converges on maximum value of adiabatic temperature rise and it maintains value. Maximum value of adiabatic temperature rise is constant. So that is what we see here. As we can section 1, section 2, section 3, and we can say it is little less difference in case of section 3. That's the important point. Also, you see, it says reason for this is the high initial rate of hydration. There is insufficient time available for diffusion of products and hydration. Therefore, hydration reaction of cement particles cannot be completely approximately, and this has negative effects on long-term strength of concrete. Now we have in this equation, you can see already has been 6. So the adiabatic temperature rise history is divided into 3 sections. Hydration, heat, almost cannot be seen. Generally, hydration heat in concrete tends to begin in a short space of time after placement. To reproduce an accurate adiabatic temperature rise history of section is a clear state. So Q is equal to K to 1 minus C R minus T minus T naught, where Q is adiabatic temperature rise at T degrees Celsius. K is the maximum value of adiabatic temperature rise degrees Celsius. R is reaction factor degrees Celsius per hour. T is age days. T naught is starting time of hydration heat. Constant T naught that has the highest reliability was conducted through regression analysis in section 1. Relationship between time of section, relationship between time in section 3. Temperature started from placing temperature. Converse is on maximum value of adiabatic temperature rise and it maintains value. Maximum value of adiabatic temperature rise. That is figure 7. It is this one. Cement contents and maximum rise. I think I should go for some time. Let me finish it. Presents this figure gives relationship between maximum value of adiabatic temperature rise K and cement content based on resulting data in this study. Generally, it's reported that maximum value of adiabatic temperature rise is proportional to binder content containing mineral admixture under similar binder conditions. In these studies found that there exists a linear relationship between maximum value of adiabatic temperature rise and cement content, excluding admixtures in all concrete mixes. It can be explained that it's possible to predict maximum value of adiabatic temperature rise from cement value of the adiabatic temperature rise. It can be explained that it's possible to predict maximum value of adiabatic temperature rise from cement content regardless of mineral admixture type, water, binder in concrete. It is observed that maximum value of admixture, adiabatic temperature rise K of per specimen with placing temperature device approximately is we consider the maximum temperature rise, and here is mixing conditions and cement content is this 524 kilogram per meter cube. So this one case, and you may see 4 degrees lower than that of specimen with placing temperature 25 degrees. What was condition 1? It was not here. I think it's alright. 4 degrees are lower than that of a specimen with placing temperature 25 degrees Celsius. Reaction factor. It was found that placing temperature effects of temperature rise ratio of concrete 5. A high placing temperature was demonstrated to be effective for making reaction factor high. High is shown as this much, high, you can say high placing temperature was demonstrated to be effective for making reaction factor high. Furthermore, it's observed that reaction factor rises linearly with cement content excluding admixture and concrete. Use of admixture and management of placing temperature in concrete are important factors. And now starting time of hydration heat. I'll be back. Okay, you can realize I can 64% and this is okay. Give me 5 minutes, so I'll be back. I hope you understand my problem. Be back in 5 minutes, so hold on. By that time I'll complete this and go to that file. I think we can continue here. This about this figure 7, which talked of it is quite okay and understandable, and we were putting in this, and we said that okay, this is figure 7 presents relationship between maximum value of adiabatic temperature rise and cement content based on resulting data of this study. Generally, it's reported that maximum value of adiabatic temperature rise is proportional to binder content containing mineral admixtures under similar binder conditions. In this studies found that exists a linear relationship between maximum value of adiabatic temperature rise and cement content, excluding admixtures in concrete in all concrete mixes. In other words, it can be explained as possible to predict maximum value of adiabatic temperature rise from cement contents regardless of mineral admixture types. It is observed that maximum value of adiabatic temperature rise of a specimen with placing temperature 35 is approximately 2 to 4 degrees centigrade lower than that of a specimen with placing temperature 25 degrees Celsius. Reaction factors found that placing temperature affects temperature rise ratio of concrete. A high placing temperature rise ratio of concrete. A high placing temperature was demonstrated. A high placing temperature was you can say demonstrated to be effective for making reaction factor as shown in figure 8. Furthermore, it was observed that reaction factor rises linearly with cement content excluding admixtures in concrete. Accordingly, use of admixture and management of placing temperature in concrete are important factors to control reaction factor at early ages. Starting time of hydration heat. Now this figure, that is cement contents here up to 600 is the frequency of 100 increase, and reaction factor here is this placing temperature 35, y is equal to 0.0054 x plus 3.3818, and r square is this placing temperature 35. This is the equation here. This is the reference and equation value and coefficient. R square is this one. So we can say why is this? What we say here is mixing conditions W over binding factors 29 to 40 unit water 160 gram per meter cube, and that is cement content is 400 to 524 degrees kilogram per meter. This figure shows starting time. So here's what we say according to use of admixture. It says can say that admixture and management of placing temperature in concrete is important factors to control reaction factor at early ages, and starting time shows starting of hydration heat. This figure 9 shows the starting time of hydration heat, that is T0 according to cement content. Increasing placing temperature and cement content, delayed starting time of hydration, that is increasing placing temperature and cement content, delayed starting time of hydration heat, T0 for concrete. Figure 8 shows relation between reaction factor and cement content of concrete, and figure 9 shows relation between starting time of hydration and cement content in concrete mixes. So what it says, figure 9 shows the starting time of hydration heat according to cement content, increasing placing temperature and cement content, delayed starting time of hydration heat T0 concrete, and here it is that, in both cases you can see that is figure 8, relation between reaction factor and cement content in concrete, and this is reaction factor, that is reaction factor. And this is your starting time, relation between starting time, hydration heat, placing temperature 25 and placing temperature 25. You can see these differences curves. And there is that. So figure 10, that is here, figure 10, relation between starting time of hydration heat and setting time of curve. And you can see here, that is figure 10 represents the relationship between setting time and starting time of hydration heat, though through experimental research in high strength concrete. It is found that starting time of hydration heat has a close correlation with final setting time. Through final setting time of concrete, early age behavior of adiabatic temperature rise history, such as starting time of hydration heat, can be predicted. Verification of KR and TO. Adiabatic temperature rise properties of concrete according to water binder and concrete content were previewed. Results of adiabatic temperature rise tests obtained in equation 3 and concrete mixing that has similar range were compared. Additionally, reliability of tests were reviewed. Now, what says concrete mixing details and setting time are given in this table 3. Concrete mixing details represented are obtained from construction sites in Korea. Concrete was made from mixing proportions with water to binder ratio 23.8% and 44%. Adiabatic temperature rise test was conducted by construction company that designate. Then designed concrete mixing, placing temperature 25 degrees Celsius and setting time in table. These are references only. So what we have actually, let's know, we have so many details here, and if you wish you can read them. There's no harm. You can hold experiment results by adiabatic temperature rise test and calculated results by production models. Now what actually they want to say, let's go to that before closing this. It's confirmed that prediction model and approach method on constant KR T0 in this thesis have sufficient reliability. In other words, through an analysis of cement content and final setting time of concrete, behavior of adiabatic temperature rise history can be predicted. And what's conclusion is, effects of cement content, placing temperature and setting time on adiabatic temperature rise history in concrete were investigated. Is placing temperature affects cement content, placing temperature setting time of adiabatic temperature rise history in concrete tested, investigated. Conclusions drawn from this study are as follows. It is found that maximum adiabatic temperature, maximum value of adiabatic temperature rise, that is K, and reaction factor R have a high correlation with cement content, excluding admixtures of unit binders content. It can be considered that cement content in concrete mixing is important factor to analyze properties of adiabatic temperature rise. In this study, adiabatic temperature rise history is divided into 3 sections. Section of no hydration heat, section of rapid temperature rise, and section of maintain maximum temperature. Among these times, section 1, that is starting time hydration heat, has to close correlation with final setting time. That means the starting time of hydration heat can be set with final setting time of concrete. Placing temperature accelerates setting time, and placing temperature accelerates setting time and starting time hydration heat. A high placing temperature was demonstrated to be effective for making reaction factor R high. However, contribution of placing temperature to maximum value of adiabatic temperature is of course low. In conclusion, it's possible to predict behavior of adiabatic temperature rise history from cement OPC container setting time. This research was supported by Basic Science Research Program through National Research Foundation of Korea, funded by Ministry of Education. Authors were supported by BK21 Plus program, Chingaon National University and Daewoo Institute of Construction Technology. And now we can say that this will go back to this, we'll find what else we can see. Study of adiabatic temperature rise, now science.com. I think adiabatic temperature, I think we have gone through well. What this research gate says, let me see, maybe they allow something on that, let us study. We have to go more, I think, let's say what the array is now, not details are available. Download full text, if I say download full text, it will ask for memberships. I'm not here interested. So I'm just reading this off your view. Says limestone fines LF is used as an inert filler in concrete. Limestone fines is used as an inert filler in concrete to reduce cement consumptions, reduce heat generation during hardening and promote sustainability of concrete construction. Basically, lime fines is added to replace part of cement paste and does not actively participate in chemical reactions of concrete strength gain. As a key factor affecting heat generation of concrete, degree of cement hydration in lime fine concrete mixes is dependent on mix proportion parameters including water content, lime fine volume and water cement ratio. Consequently, heat evolution of LF concrete is dependent on these mix parameters in a complicated manner, and this renders the effect of lime fines on heat generation and temperature rise of concrete difficult to quantify. So this paper reports an experimental study of adiabatic temperature rise of LF concrete is lime fine concrete. 20 concrete mixes were with lime fine volume at 0 degrees, 40 degrees, 8 degrees and 12 degrees. 0%, 4% is lime fine volumes at 0%, 4%, 8%, 12% were tested using semi-adiabatic curing test method. With heat loss compensation, it was demonstrated that addition of lime fine could effectively suppress temperature rise of concrete based on experimental results, production formula and design chart of adiabatic temperature. So let me see if we can download this mutate next time also. I'm sure we don't allow this per my experience. So let me see if we can do that. Discover what is join for you. That's the problem. Then I'm not going to join, leave it. Who's time for this? Don't waste time now. Now there's a research cat. Adiabatic PDFs, adiabatic temperature rise of concrete with limestone. As it says, same. I think there's no difference. It's same. And methodology comparison for concrete adiabatic temperature, QD in 2019. That is what it says. This methodology is about that. Something happening. Sometimes international concrete abstract water. So let us see this. Let's read abstract just a small. Concrete adiabatic temperature rise is often used. Concrete adiabatic temperature rise is often used to predict temperature. To predict temperature development of mass concrete. Thermal control plants. Several experimental methods are currently being used to obtain adiabatic temperature rise. This study compared adiabatic temperature rise from 7 concrete mixers obtained from fully adiabatic, semi-adiabatic and isothermal calorimetry. Study found a low adiabatic temperature rise difference between semi-adiabatic calorimetry and fully adiabatic calorimetry for ordinary Portland cement concrete mixtures for 28 days and for mixtures containing class F fly ash during first 10 days after mixing. Semi-adiabatic calorimetry did not match well to fully adiabatic calorimetry results when slag cement was used because rate of heat development could not be well described by a 3-parameter heat of hydration model. Adiabatic temperature rise calculated using isothermal calorimetry results did not compare favorably to measured fully adiabatic results, even when temperature effects on hydration rate were accounted for using an Arrhenius apparent activation energy approach. This was 3rd January 2019, and I don't think there is any indication that I can download this. Available in my SCI store, exports and usage. Well, there is no way that I can download this. This is maybe they don't want others to. It says journal, SCI structural journal magazine. So, well, we cannot get it. Leave it. Just want to publish in journals only. Cement and concrete research, determination of temperature rise, study of temperature. So we go back now. I think its purpose is over. We have to go back to our own tape. So we are talking of this at least. Now I'm back on this paper. That's our own, and we say we were here somewhere an adiabatic issue that came in. So let's interact with that. I close that one for time being. I like to close it. That one no use now. No use now. So I close that one. Now come back to our own talk. Already many hours are gone. It's gone 2 hours 34 minutes. So type B blast furnace slag cement is effective in reducing alkali silica reaction, chloride infiltration. Type B blast furnace slag cement in disintegers, however, tends to be formulated so that depending on slag content, powder content, initial strength becomes high. Consequently, there are cases where adiabatic temperature, there are cases where adiabatic temperature rise rate of concrete is higher. Adiabatic temperature rise rate of concrete is higher than that of normal Portland cement, and there have been reports of increase of cracks due to thermal stress depending on member sizes, constraint conditions, environmental conditions. Since type B blast furnace slag cement includes low heat types, it's important when using it to check on its thermal and other properties and guarantee strength at relatively old material age. Thanks to recent advancement in production technology, thanks to recent advancement in production technology, today it's possible to achieve required strength of cement even if water cement ratio is high. Cement today, therefore, is capable of meeting high early strength oriented performance requirements, aiming to achieve required strength at a material stage 28 days. Some point out, however, that result durability suffers. In coming years, there will be need for cement that develops appropriate strength at water cement ratio determined by durability, and that cement that has different strengths for concrete with different strengths. In this case, however, securing that takes early age strength development into consideration is important. Eco cement, which was newly standardized in 2002, can be largely classified into two types: normal eco cement and rapid hardening eco cement. Eco cement which contains chloride ions. Eco cement which contains chloride ions in quantity equal to 0.1% or less of mass of cement has properties similar to those of normal Portland cement. Eco cement has made applications to ordinary agents for concrete possible. If quantity of Na2O or K2O contained in cement is large, particular type of minerals in aggregate may cause alkali silica reaction under certain conditions, thereby causing deterioration of concrete. Appendix 2 regulation methods for suppressing alkali silica reaction. describes three methods for preventing or reducing such alkali silica reactions to choose from. Number one, reducing total alkali content, total quantity of alkali supplied by various materials of concrete when Na2O equivalent of 3 kg per meter cube or less. Using blended cement is number two, using blended cement containing reaction suppressing effects such as type B or type C blast furnaces like cement, or type B or type C fly ash cement. Using aggregate that has been judged to be harmless. With respect to alkali silica reaction control methods are described in greater detail in explanation of item 4 in section 4. So it says first is reducing total alkali content, that's total quantity of alkali supplied by various materials of concrete when Na2 equivalent to 3 kg per cubic meter or less is. Then 2 is using blended cement containing reaction suppressing effects such as type B or type C blast furnace slag cement or type B or type C fly ash cement, and using aggregate that has been judged to be harmless. With respect to alkali silica reaction control methods are described. Okay, now cement used mainly for civil engineering projects include not only types specified in this but also cement with special performance characters. Use of ultra rapid hardening cement makes it possible. Use of ultra rapid hardening cement makes it possible to achieve high strength in a short period of time and begin to use the structure in only several hours even in winter. Use of ultra rapid hardening cement makes it possible to achieve high strength in a short period of time and begin to use the structure in only several hours. Begin to use the structure only several hours after even winter, since consolidation and hardening purpose of cement of this type vary considerably depending on quantity of hardening time modifiers used. It's necessary to obtain accurate information on consolidation properties at temperatures at which cement is used. Other special types of including cement include ultrafine cement, alumina cement, oil well cement, geothermal well cement, white Portland cement, and colored cement. When deciding using these special types of cement, it's a good practice to carefully study past construction records and conduct thorough tests in advance. The use of combination of two or more types of cement may result in an unexpected results, such as quick setting of mixture of alumina cement and Portland cement. When mixtures of different types of cements are used, it's necessary to ascertain that such mixtures would not have adverse effects on performance of concrete. Mixing water should be tap water complying with provisions, and recovered water shall meet requirements described in seawater should not be used in mixing water in general. And mixing water must not contain substances that cause consolidation or hardening of concrete. Mixing water must not contain substances. Mixing water must not contain substances that cause consolidation or hardening. That cause consolidation or hardening of concrete, hardening of concrete. Stem development, volume changes, degradation in quality such as workability or steel corrosion in harmful quantities. In many cases, water that does not have any unusual taste, odor, color or turbidity and that is suitable for drinking can be used for mixing of concrete. Water that does not have any unusual taste, odor, color or turbidity and that suitable for drinking can be used for mixing concrete. Suitable water, surface water, water from rivers, surface water, water for rivers and lakes, groundwater, industrial water, etc. may be used as mixing water. Surface water, water from rivers and lakes, groundwater, industrial water may be used as surface water. River, pond or lake water may be contaminated by industrial wastewater or sewage and may contain sulfates, iodides, phosphates, borates, carbonates, compounds of lead, zinc, copper, tin, manganese, etc. Inorganic alkali compounds, organic impurities such as sugar, pulp, wastewater, or corrosive materials. Presence of even very small amount of these impurities in mixing water of concrete may have adverse effects on concrete properties such as setting, hardening, strength development, volume changes, workability, etc. When mixing water containing chlorides, nitrates, in mixing water containing chlorides, nitrates, sulfates, etc. is used for concrete, corrosion of steel may be accelerated. In particular, for highly stressed pre-stressing tendons. In pre-stressed concrete, stress corrosion is likely to occur. Stress corrosion. In steel, where a stray current flows, stray current flowing, electrolytic corrosion may be accelerated. Therefore, in cases of using water other than surface water as mixing water should conform to requirements. Recommended practices for quality of mixing water for concrete and Appendix 3, water for mixing and ready mixed concrete. Supernatant liquid of washing water. Supernatant liquid of washing water in mixers, truck agitators, etc. at ready mixed concrete plants or precast concrete plants may be used as mixing water if it has been ascertained that there has been no adverse effects on strength, workability, etc. of concrete. Sludge water with suspension of cement and other fine particles generated when aggregates are covered from excess concrete or from mortar. We use mixing water. If its suspension concentration ratio of quantity of suspended solids to cement content, etc., can be controlled adequately only after it is ascertained that there will be no adverse effect on quality of concrete, since however recovered water contains chlorides and alkalis, it is necessary to consider their concentrations being before using recovered water. Only recovered water meets requirements described. If seawater is used, old age strength of concrete becomes smaller. If seawater is used, old age strength of concrete becomes smaller. Concrete becomes more prone to efflorescence and concrete becomes less durable. Use of seawater, therefore, is usually not permissible, since well water near a sea coast often contains chlorides. Seawater may be used only after chloride content is checked. In case of plain concrete without non-structural reinforcement, seawater may be used, in case of plain concrete without non-structural reinforcement, seawater may be used as mixing water after ascertaining that there is no adverse effect on quality of concrete. So I come to aggregate. Fine aggregate. Fine aggregate shall be clean, hard, firm, durable, chemically or physically sound, and not contain a harmful amount of dust, mud, organic impurities. Organic impurities, I just put this in way to let people know who is this, and there is certificate, this quality file, and this is coalition file, concrete GCC. So we can say fine aggregate. Fine aggregate. Fine aggregate shall be clean, hard, firm, durable. See, clean, hard, firm, durable, chemically or physically sound, and not contain a harmful amount of dust, mud, organic impurities, etc. What sequence is? Clean. Clean. We are talking of sand or dust. It should be clean, it should be hard, not soft. It should be firm, it should be durable, it should be chemically or physically sound, and not contain a harmful amount of dust, mud, organic impurities, chlorides, etc. Fine aggregate should comply with table 341 properties and fine aggregate. Oven dry particle density gram per centimeter cube is more than equal to 2.5, that is quality. Then water absorption percentage less than equal to 3.5, and clay lumps less than 1, I think less than 1. What is that? Let us see fully. That is less than 1, and particles passing standard sieve, size sieve 75 micron milli, when concrete surface is subject to abrasion percentage, how much, and other than above. So when particle size passing sieve size 75 mm less than equal to 3, when concrete surface is subject to abrasion less than equal to 5. Organic impurities darker than standard color or sample color, and of course container of chlorides less than equal to 0.04, and soundness percentage less than equal to 1. Test samples are residual materials on sieve after test. Test samples are residual materials retained on sieve after test. In case of crushed sand or slag fine aggregate, if washed out, materials consist of dust from fracturing and are easily free from clay, essentially free from clay or shale. These limits may be increased to 5 and 7% respectively. This value is a percentage for oven dry mass of fine aggregate, as shown as valuable covered in ACL. So what is that? In fact, we are talking of fine aggregates. You can say organic impurities darker than standard color or sample color. Contents of chlorides less than equal to 0.4. 0.04. Soundness is less than equal to 10. Test samples are residual materials retained on sieve after test. This in case of crushed sand or slag fine aggregate, if washed out material consists of dust from fracturing and are essentially free from clay or shale. These limits may be increased to 5 and 7% respectively. This value is a percentage for oven dry mass of a fine aggregate and is shown as value converted to NaCl. Crushed sand should comply with provisions that I know. Blast furnace slag fine aggregate, ferro-nickel slag fine aggregate, blast furnace slag fine aggregate, and ferro-nickel slag fine aggregate. We can say blast furnace slag fine aggregate, ferro-nickel slag fine aggregate, copper slag fine aggregate, and electric arc furnace reducing slag fine aggregate should comply with provisions specified in this. Recycled fine aggregate should comply with provisions specified. This, the grading of fine aggregate should lie in range specified in this table 342 down, with appropriate mix conditions of large and small particles, and here is standard grading of fine aggregate, nominal opening of sieve size and percentage of mass passing through this sieve, normal opening of sieve and percentage of mass passing through this. I'll take up this. Of course. Now we are talking quality and coordination, and this is a very, very important one. We cannot avoid this at any cost. We have to be very serious in this issue, because talks is not jokes, and this issue of engineering knowledge, which we very rarely people don't treat this. I try to get information from internet and through papers and through various postings, various files, and we have to get information. It's not necessary, because quality cannot be achieved in universities. You cannot learn quality in universities. You cannot learn quality in universities. There's no such you can say topics or subjects are available in graduation, post-graduation, etc. We have to graduate ourselves without any. It's very easy these days to get competent information, consistent information from the use of internet. Sometimes we get, sometimes we don't. But my concern is that I've tried many times, many times during my session. Tried many times, and otherwise also I tried many times to get more information of quality and coordination. But it's unfortunate that I'm not getting any practical information from engineers. This information which are getting, these are very rare from practice field. And I don't say this is not reliable, depends, but why I'm concerned is that we are not oriented till now. We are not oriented ourselves towards engineering quality, production quality, manufacturing quality. And of course, because being cultured country everywhere has faiths and all fear faith. Nobody bothers, nobody speaks about that. That's a very, very dangerous issue, you can say. I have worked in many places. I like to show you just the information brief, which is I tried many times, so I forgot all times. Just a little brief. I don't know I got file or not. IP certificate, number data channel chamber model, farmland and data. Well, that's a good file. I just had a thought to discuss that one with you. But I think let me go back to my search file and see how does it work. It should be immediately seen. I think it should be available within minutes if I can see that. That is I should get it now. I think it should be here. And this is no, it's not IP. I'm sorry, it's arbitrator I'm looking for. I have to see an arbitration application, not in this one, and that should be here somewhere. Yes. I've seen this now arbitration issue comes in, and I have to see response. IT agreement. I see FI arbitration dispute. File response. Yeah, I got it. This is on 15th January. I sent back. That's one part. I think I just discussed this with you. It's also important. Just few reference to my past career. Actually, this is my professional career. For details, okay, still kindly refer to already submitted CV. This was sent in response to my application to Institution of Engineers India. I sent long back. In this case, I'm showing, let's say, there are some companies here. I try to show my claims issue also here. May say claims issue. And I'll create my CV also to you in details. Let me just tell you my career. I started my career in 1975-81. I worked for 6 years in Delhi Development Authority as junior engineer civil. I worked in Ansar Properties India Limited, April 1981, that was in Iraq. I worked there for 0.5 years as junior project engineer. Then in another organization, that is in Ansel Service April Limited, April 1981. And then I joined European Associates in UK in 1982. Associates UK, not in UK, Associates UK. 1 year for 1 year worked for them, project engineer, site manager, Iraq Baghdad, Site Chick India Limited 1983. 0.25 years, senior site engineer Baghdad. Electrical construction company Eco, electrical construction company Eco, government of India and government of Libya, Socialist People's Libya, Arab Limaria, joint venture 1983-84. And I can say I worked in, this was project engineer site manager, Libya Tripoli Benghazi Sir. And I worked as Alatia Contracting and Trading Company, Al-Qaid, Qatar, Doha, 1985-1989. 4 years, site agent, contractors agent, and project engineer, Qatar. And Sky Associates Delhi in 1989, 1994, so my own practice, was consultant, planner, designer. And with Mac, Lebanese company, 1995-96, 1 year, project office engineer, Qatar, Raslahan, LNG and Villa. And then Khalsa Contracting and Khalsa Contracting Trading, 96-98. This was 1.5 year, chief engineer, UAE Abu Dhabi, and of course, then Khalsa Contracting, and as I said, Khalsa Contracting Trading, 96-99, chief engineer, UAE Abu Dhabi, and then Al Jaber Energy Services, UAE, 3.5 years, project office. Not project office, this is for project office of site, yes, UAE Abu Dhabi. At Ruwais, that was in Ruwais 1999-2003. And then the housing designs, constructions of house 2008. Then 1.5 years of honor of that, my house I did myself. And Pat Engineering 2010, 1.5 year, project manager, Qatar Doha, Alawi Tunsi company. Establishment 2011, I worked for 0.5 years, project manager, Kesida, engineering and arbitration consultancy 2012-16, 5 years independent India, and of course, there's then there's independent practice, and that is after my arbitration consultancy in India for 5 years, and then independent practice, current knowledge dissemination online, like I'm doing now. It's knowledge dissemination, what knowledge I have, I'm trying to share with you. And other than this, you can see this is about 38 years total here, and 36 years, and then we have particularly 20 years in contracting companies. Then we have building practice and books written, and not online engineering activities as I'm doing, involving contracting, contour, designs issue being derived. So we can say comprehensive experience, 37 years total, including about 20 years in international contracting. In addition to above, building practices, books are written, lot online engineering activities involving contracting, quality and coordination, designs issues being deliberated, the response to point on, oh, okay, I'll take some other issues later on and I have to close this. It's already 3 hours lapsed, so I just try to show you my involvement in this, and that's really very important point. And you can just see these files again to show you, and that's what is happening. Also, we can say we talk retaining rate. I'm just trying to say that it's not necessary you should be somewhere, it should be everywhere. So I close this file. I try to get I'll try to show my CV file as well, as it's necessary to show at this moment. Just a glimpse of what you can see. But that's not be. Oh, okay. Let's what's that? I think let me print it better. Is this open with? It's going to open this. Let me open as it is and print it first. I think that's the only way. Let me print it and see how to just show you glimpse of that. Not word form you can say, but in print form you can say. So let's do it. It's coming only a few pages, maybe it's done. I think it's come. So this is come. Okay, that's fine. So this is my CV file. After 21, 22%. So we'll take up this issue also. It's important also, no, it's not here. Just for this, I'll say it's gone quite long. It will take much time, so it is in general records and goes to II application. Is that March, so this is here, and I can say that I save it as it is, a PDF format. I will discuss it next time. I close it now, and I close all other files as usual. And we'll I think it's time now. I don't feel bored, and let's close this file first of all. So I'll take leave now. I'll see again.